34,000 tons of iron ore, a train 1.7 miles long, zero diesel fuel. Mining companies burn 21 million gallons of diesel a year just moving rocks. Fortescue Metals decided to stop. They built the Infinity Train, a 14.5 megawatt-hour rolling battery that uses the sheer weight of its own cargo to generate free electricity. Here's the hard data on how gravity-powered rail actually works, the massive battery specs, and the brutal physics reality check that forced a major pivot in 2026. This is Iron Chronicles. We're skipping the history lesson and looking straight at the heavy metal. The Infinity Train is the largest land mobile battery on Earth. It's designed to run entirely on the laws of physics. Let's break down the numbers. The Pilbara region in Australia is brutal. Fortescue operates 70 locomotives there, burning 82 million liters of diesel annually. They needed a zero-emission heavy hauler, but you can't electrify 385 miles of desert track. The trains had to carry their own power. The solution was dynamic braking. When a 34,000-ton train goes downhill, it has to brake. Standard diesels turn their traction motors into generators, converting kinetic energy into massive amounts of electrical current. But standard diesels just burn that electricity off as heat through roof vents. Fortescue stopped wasting the heat. They bought Williams Advanced Engineering, a Formula One tech company, to capture it. The train loads up with iron ore at the top of the mountain. As millions of pounds of rock roll downhill, the motors generate electricity. But instead of venting it, the power flows directly into a massive onboard battery. Gravity charges the train. To catch that much energy, you need unprecedented storage. Fortescue partnered with Progress Rail. They built a locomotive packing a 14.5 megawatt-hour battery system. Let's put that in perspective. One standard Tesla Model 3 holds 82 kilowatt-hours. One single Infinity locomotive holds the energy of 176 Teslas, and a heavy haul train uses 2 of them. That is nearly 30 megawatt-hours of lithium-ion storage rolling down the track. The batteries also solve a major railroading problem: weight. Locomotives need to be incredibly heavy so their steel wheels grip the rails. By swapping a 30,000-pound diesel engine for solid battery racks, the train maintains the brutal weight needed for traction. Plus, electric motors deliver 100% torque at 0 RPM. It rips 244 loaded cars from a dead stop better than any diesel on the market. The original theory was perfect. The heavy train rolls down the mountain, fully charges the battery, dumps the cargo at the port, and uses that stored power to drive the empty train back up. Infinite momentum, zero external charging. But physics always wins. In 2025 and early 2026, real-world testing shattered the infinite concept. Mechanical drag from steel wheels, aerodynamic resistance from 244 cars, and heat loss in the electrical inverters bled too much kinetic energy. The downhill run simply cannot generate 100% of the power needed to go back up. You can't cheat thermodynamics. The project didn't fail, but it had to pivot. Fortescue is still rolling out the beasts, but they changed the math. The 2026 data proves gravitational braking recovers 40 to 60% of the train's total energy. Getting half your fuel for free just by rolling down a hill is a massive financial victory. But to cover the missing 50%, Fortescue built infrastructure. They constructed 100 megawatt solar farms near the unloading ports. The news cycle is brutal and efficient. The loaded train rolls downhill, generating half its power. It parks at the port. While automated machines take 2 hours to dump the ore, the locomotive plugs into the solar grid. It fast charges the rest of the battery using pure desert sunlight. Once charged, it throttles up and heads back to the mine. The pure Infinity Train, a perpetual motion machine, was a mathematical impossibility. But the attempt created a 30 megawatt-hour heavy metal monster that is actively killing the diesel engine in the Australian outback. It proved you can move the heaviest cargo on Earth using nothing but gravity, sunlight, and raw engineering. What's your take? Is saving 50% on fuel worth the massive upfront cost of these battery giants? Let me know in the comments. Hit subscribe for straight facts on extreme machines. This is Iron Chronicles. See you on the next run.